be talking about managing a large-scale application written in PowerShell. Thanks to our sponsors. If they weren't here, we wouldn't be here. So, like I said, my name is Bruce Payette. I was a founding member of the PowerShell team. I was actually on the PowerShell team before Jeffrey was on the PowerShell team, which is interesting. Yes. So I was a lead architect on the language, and I also invented PowerShell DSC, and I wrote about a book that people seem to like. I was at Microsoft for about 18 years. I was at Amazon for a couple of years. But this stuff is all personal. I wanted to write a large application because we'd never done it. Right? The PowerShell team writes everything in C#. We write small scripts and so forth here and there, but we've never written something in the scale that some of the users are experiencing. Like Jakub was saying that Pester is 25,000 lines of code. So, I mean, that's much beyond the scale that most of the people on the PowerShell team have ever written. So I decided that I wanted to write a large application. So what does a large application mean? All the words are important. An application is a non-trivial user experience, something like a text editor or an IDE, a database, or a programming language. I arbitrarily chose large to be 10,000 lines of code or more. That seemed like a reasonably large number. And then maintain means that you work with it over a period of time. It's not something like you work on it for a month and say, yeah, I'm done, and move on. You work over at least several years. So a tiny project. I decided, because I'm me, that I would write a programming language interpreter in PowerShell. Purely in PowerShell, not using C#, not using any other tools. And the result is around 12,000 lines of PowerShell code in one file. It's too big for VS Code. VS Code just kind of gets lost. It's unfortunate. VI works quite well. And about 13,000 lines of code in the actual programming language, in the actual tiny programming language. And I've built and maintained this over about the last 3 years. So I'll work on it for a little while, do some debugging, add some more tests, fix a feature, add a feature, then put it away for a little while, pick it up 6 months later, deliberately to make sure that the experience in maintaining a large program was feasible. So here's some examples of Tiny itself. Let's flip over to do, come on, flip, there. So let's start Tiny. It starts quickly because I already have it loaded. So, crap. Yeah, I do. Maybe this will be better. Okay, that's better. It's not very bright. Anyway, so we started Tiny. It started quickly because I had loaded it already. It's big enough that it takes a few seconds to load normally. So it's a programming language, interactive programming language. So math, it does math, obviously. It has precedence. So there are modules. You can see what's in the math module. Right, so we'll get the square root. So basic arithmetic operations are just work. Functions, add. Aha. So create a simple function. If we want to have more than one, this is if you have a single expression, it automatically returns the result. If you want to have a slightly more complex function, right, so it returns the value of the last line. There is a return statement, but it's optional. It wraps PowerShell's functionality, so I can do ls. Get just the tiny files. If I want to pass arguments, I have a rather clunky mechanism for doing that. So the operator star dot applies the property reference to all of the members of the collection. So if you're aware of in PowerShell, when we did workflow, we added this thing where if you dot a property and that property is not on the object, then it will look at inside the collection for individual, which gives some fairly weird results, and it's hard to debug. So I thought I would split it into two operators, star dot for the contained properties and star or dot for the top level properties. So we want the total length of all the files. Let's do something a little different. Well, that's interesting. Oh, I know. It's when you call read line instead of read file. So it gives me, this is a count of, a list of the counts of all of the lines in the tiny files recursively. And again, I can sum them. So it's pretty quick for things like this. More complicated programs are slower. Let's see if there's anything else I want. Oh, yes. Just because I like this example. So what I'm doing now is defining a factorial function that takes a single argument n. It uses the range operator 1 ... to produce a collection of n integers. And then I use the reduce function, which takes two arguments, the previous and the next, and I'm multiplying them together. So that gives me infinity. There you go. Built a bunch of tools, unit testing and the test directory. So let's look at those files very quickly. Now, I could have written everything in Pester. That would have been a logical thing to do, but I'm testing my programming language. So by writing the test suite in the programming language, I am dogfooding again. So there's some stuff at the front to do get ops in a rather clumsy way. And then, but most of the actual tests are embedded in the PowerShell source code. So this script goes through the source code, extracts all of the tests, runs all of them, and then gives you the results, which is why you don't see any tests actually in the code. You can see that it looks like actual code. And documentation is the same sort of thing. So Braid is set up to allow you to, not Braid, Tiny, sorry, wrong language. Gives you kind of a DSL for building HTML documents. So all the body tags and so forth. And then again, a lot of the documentation for functions and operators is embedded in the source file, the PowerShell source file. So this tool extracts that documentation and generates HTML out of it. So those are tiny tools. There's a set of modules. for various types of things. And you'll notice that the modules can either be written in Tiny or in PowerShell. As long as they return a hash table of properties that I can execute, it works. Actually, let's see. You can see here that there are some of the members on that module are written in Tiny. Some of them are just method infos from the various classes. A bunch of them are script blocks. Again, it's just the method info. So the contents of a module can be varied. So challenges to building a large application. Source code organization is a big one. And I don't have a good answer for this. A large amount of source code, you have to have some kind of reasonable organization so you can maintain and version and manage and all that kind of stuff. PowerShell provides modules, but modules are a way of exposing library functions. They're a little bit much overhead for a lot of the things you want to do. An example is an enum. If I wanted to do an enum, if I used a module for that, that's a lot of overhead. So what are the mitigations? Well, you can do dot sourcing, so you could have your script in a subdirectory containing the component scripts. The top level script would then dot source all of the individual scripts. That means you have to maintain the dot source scripts, and the thing that's doing the dot sourcing have to be kept in correspondence. I have seen some discussion of people, rather than explicitly dot sourcing all of the modules, they just do for each file in my directory, please import. And that's a little terrifying from a security perspective. If somebody drops something in there, you're screwed. So I wouldn't recommend that. The concatenation model, you could write a tool that just took all the individual files and concatenated them into one big-ass file. But then you lose all of the line numbers, the correspondence between where the line is in the generated file versus the line in the original source file. You have a hard time mapping them back. So that's not a great solution either. The one I went with was just one big-ass file. And it's simple. You can just distribute the .tiny.ps1 file. You run it just by running the script. So as a unit of distribution, a script is a good atom for that. But we need to have a better solution for this somehow. Challenge 2 is namespace management. So once you get into, I'm sure Jakub has run into this, once you get into a large application, you have a lot of names lying around. Functions and constants and module names and so on and so forth. And using the traditional PowerShell abstractions of hash tables and things like that, it really becomes unmanageable very, very quickly. Again, you have the module mechanism, good for sharing code for libraries. It's not great for this type of thing because it's a little heavyweight. You could use dynamic modules and closures, PowerShell dynamic closures, which somebody is giving a talk on at some point this week. But again, they're pretty heavyweight. So, well, I'm not going to explain what a closure is again. So my solution was to use classes, because that's what they're designed for. They are oh, okay. So a closure in PowerShell is essentially an anonymous module that you can take a function and bind it to that module, so it executes always executes in the context of that module. So, like I've said, classes are data with code attached, and closures are code with data attached. So the closure carries around its own environment. But that environment is an entire session state. So it's a little heavyweight. If you create a lot of those things, you're going to have a pretty high memory footprint. The question was, what is a closure? There. I'll get it eventually. So anyway, the solution was to use classes. And it works really well. I am so impressed. We spent a lot of time designing how classes should fit into PowerShell, and I think we did a good job. I didn't write that. Jason Shirk wrote that stuff. So let's take a look at the PowerShell code itself. lovely pink text. You can see here what I was talking about with the documentation is embedded into the source file using comments that start with an O for operator documentation, H for function documentation, L, there's a core data type in Tiny called a tiny list that has a whole bunch of operations on it. And then G for the grammar. This is the same thing that I did with the original version of PowerShell, was to embed the grammar into the source code, and then you could extract it with a tool afterwards. Then you have tests are of this form. So you put a hash T and then your test text, and it'll be picked up by the test tool. If you're running on Mac, then it'll pick up the hash M's, or the hash X's for Linux, etc. So that's just some of the documentation conventions. Using namespace is a huge advantage. It means that you don't have to write the long type names over and over and over again. So this is a super useful thing. I had to include the automation.internal because it has system.automation.internal.null. And you have to be able to test for that in certain cases. And I can explain why that exists afterwards. So here's the parameters to it: script to run, expressions, so forth, so on and so forth. Nothing very special there. Debugging function. This is a very simple little function. It doesn't do very much. It just echoes its arguments to the output. But it's not called write host. It doesn't have the name of any commandlet. So it's very easy to find in the source code. So if you are leaving in says that are outputting in your runtime, then it's very easy to search for them, especially if you left align them in the code. So this was actually like super important when I was debugging this stuff. Set strict mode latest. That has its pros and cons. It means you pick up all of the strict mode stuff, but if you get a new version of PowerShell that has even more strict mode tests that you haven't accommodated in your source code, then moving to a new version of PowerShell with -latest will cause your code to break. So you're better off tying it to a specific version. Regex cache, I use a lot of regexes in this, so I'm setting the cache size to be fairly large. This weird thing, the matches variable only comes into existence after you call .mash or -match. That causes problems. If you're depending on that variable existing and you are in strict mode, until you actually do that first call, the variable won't be there and you'll get an error. So I have this little thing here that makes sure that that variable is set. So I was saying earlier enums. So this is great, right? I have all of the token kinds have named entities associated with them in an enum. I have my classes are encapsulated in a token, or tokens are encapsulated in a class. Tokenizer state is managed in a class, so I can push and pop the tokenizer state. Again, you could do this with a hash table, but I wouldn't recommend it. I mean, the nice thing is we have strongly typed properties. And you can't accidentally create a new property on a class, unlike what you can do with a hash table, and hash table members don't have types. There's a basic tokenizer. This is not a great thing. You have to maintain two tables in correspondence. This would probably be better generated. But it works. It doesn't change. At this point, with the language being fairly stable, it doesn't change very much. So this is tolerable, but it is definitely a possible source of interesting errors. The eat white space function, always important. So I have my own tiny exception class that's used for all the internal exceptions. That way I can tell they're my exceptions. They're tiny thrown exceptions, not runtime exceptions. So I can allows me to differentiate on type between system, like internal PowerShell exceptions, and then exceptions coming from the top level language. This is not usually a problem unless you're writing a programming language. And the exceptions store the tiny stack and also the PowerShell stack. So you can see things in context of the script you wrote, and then for internal debugging, you can see it in the context of the PowerShell line that caused the problem. So managing the channels of errors and information is really important. I have a common error handling function. Then all of the different exceptions. Let's jump ahead a little bit. Right, so expressions. So every expression in PowerShell or in Tiny derives from this class, and they all must implement the eval function. So this basically represents the expression tree. The source code from the script is compiled into a tree and then recursively evaluated. And so assignables are derived from expressions, and then all of the individual assignables are derived from the assignable class. Literal base class and so forth. So this represents the compiled tree. Tiny supports patterns, so it has a pattern as an R value and an L value. So you can assign to a pattern and have it broken up into pieces, or you can use a pattern, pass around patterns as first-class objects. Here are some of the tests that I was talking about. This is for expandable strings, so strings that contain embedded variable references. I have a bunch of tests here that are right next to the code. And I love this. It means that if I get a test error in my test suite, I just look for that in the source code, that test name in the source code, and I find not just the test, but the actual source code for the piece of code that's causing problems. And for this project, it worked really, really well. So one of the features of Tiny is it has regular expression literals. I talked about this a little bit with Braid as well. Having a regular expression literal means that you can you can validate your regular expressions at compile time and generate a compile time error if your expression is invalid. So that's kind of a win. And you can also have variable semantics, whether you pass a string. If you pass a string, then you do a string match. If you pass a regex literal, then you do a regex match. So it gives more flexibility. So this is an example of an assignable. A variable is an assignable. A read-only variable, this is actually misnamed. This is actually a sync variable. You can assign to it, and the output gets discarded. There's a separate class called a separate class that's a constant, and assignment to the constant classes cause an error. Type constraint. So if you have a variable that has a type associated with it, then this is the class that'll be used. And variables are a pattern matching thing. Here's the constant class I was talking about. And then pattern, so all of the pattern classes have pattern base, and then they derive from that. So I'm spending too much time doing this. So that's sort of some of the techniques that I used. Earlier today, Fred did a talk on some best practices, and I'm definitely including the best practices. So naming and all of the things that PS Script Analyzer gives you are definitely good things to do. This is stuff that you do on top of it because you have a very large application. Challenge number 3, this is a big one for making a reliable program in PowerShell, is cardinality. When you return a value from a function, you don't know whether the input was a collection or not, because it just strips it down to a single object. So it causes unexpected results. You think you're getting a collection and you're not. And likewise, the output types of functions. The type constraints on functions are just a suggestion. They aren't nominal or normative rather, and so it doesn't help you catch errors. So mitigation using strict mode, as I talked about earlier. Latest has certain problems, but methods and classes are strongly typed. The return type is strongly enforced. If it says it's going to return an array, you know it's going to return an array. And so that eliminates a certain class of PowerShell bugs that happen because of the scriptiness, because this is much more of a programmer model. PowerShell is an elastic language. It goes from very high-level one-liner scripts to something like this, where it's a classical programming application. Performance. Excellent that we had the performance talk right before this. So PowerShell function invocation is slow. The same complex parameter binder logic is used all over the place, regardless of whether you have one parameter or 10. And when you start doing parameter binding, what it's doing is it's doing a breadth-first search through all of the possible matches for all of the possible parameters, including direct matches and type conversions. And that makes it slow. I'm sure we could speed that up a ton by doing essentially call site caching, but that has not showed up as a high order bit for the PowerShell team yet. But there is a mitigation, and that's to use classes. Again, rather than using functions, you use static methods. Let's take an example. So here's the PowerShell Fibonacci function. All it does is call itself a lot. And here's the equivalent as a static method. So I have a fib class that does it. It's identical code, except that it's done as a static method. And let's see. Well, we'll ignore that and just go to the canned results that I have. So here's the relative performance. Running the function takes 1.5 seconds, and running the static method takes half a second. So it's about 3 times faster. This is pretty much universal. If I have a sudden performance regression in my code, the first thing I do is check for a function. Because if there's one function in there, that is your performance hotspot. If you have a lot of functions, then you're not going to notice. But it can just improve performance like 300% on your script if you get rid of all your functions and replace them with static classes. There's a certain cognitive overhead, but it's not that much. It's entirely reasonable to deal with. Challenge 5, we talked about this already. I could have used Pester, but it was simpler to use a tiny DSL for tests and to embed tests in the source file. So here are my tests. Take a quick look. So this is what a test looks like. So here I have a suite called statement tests. A test takes a name, it takes a test block, and then it takes an expected result. This is like generic, right? It's not nearly as sophisticated as Pester. It doesn't have all of the helper methods and so on, but it took about 20 minutes to write, as opposed to Pester. There's a certain, you can get to like 80% in almost no time, and then that last 20% takes you the rest of time. So yeah, tests are Mac OS or not, Windows, test this thing, test Mac. So these are higher level tests that test features in more detail. Documentation, again, the same thing. I have documentation. It's actually written in Tiny using an HTML-style DSL. I'm thinking about changing it so that it generates Markdown. You'd still use the same source code, but the output driver would be for Markdown instead of HTML. that should be pretty easy to do. So in summary, within performance constraints, so I've been maintaining Tiny for about 3 years. I pick it up every couple of months and do a little bit of fiddling around with it, and it has been stable. It went through an unstable phase early on in the development, but since then it's been very stable. I'm able to make significant changes to the tool without breaking stuff, and a lot of that has to do with using classes, strong typing, and like if you don't reference a variable in a class, you'll automatically get an error. It does a ton of really useful stuff. So it's entirely possible to build a large PowerShell application. Performance considerations, however, are limiting. You can only write something so fast. So the original version of the braid language I talked about yesterday was actually a Tiny script called Tiny Lisp. So I started writing the Lisp interpreter, and I got to a certain point, and then it was just too slow to use because Tiny is too slow. So I renamed it. I rewrote it in C#. I don't know if anybody noticed in the talk yesterday, the extension for a braid script is .tl. That's because it's Tiny Lisp. I never changed the extension. So most of the significant challenges to writing a large application can be mitigated. And this surprises programmers. Programmers don't think you can write a large application in PowerShell. Even the PowerShell team not everybody's convinced you can write a large application in PowerShell. And so I wanted to prove that you could, because I was pretty sure you could. So most of the challenges can be mitigated. The packaging is still a problem. Just before I left Microsoft, I started working on PowerShell in application mode as an aspirational goal, having a better way to deal with PowerShell as an application, but that never went anywhere, unfortunately. It would be nice to see that revived. So the code is all available on GitHub now. The deck and the code is available. So feel free to give it a poke if you want. Otherwise, thank you for coming to my talk. So if anybody has any questions, I'll be happy to answer them. Yes? Yes. Right. That will suck. Absolutely. I was the only developer on. Oh, sorry. He was asking. The single file model is not great for version management because you can end up with collisions when you're doing the differences. Yeah, you will. Yes, absolutely. So I talked about the various models. I picked the single model because I was a single developer, but it doesn't lend itself well to version control. So again, I don't have a great solution for that problem. It's something I think needs to be solved as PowerShell goes forward, but I don't own that anymore. Yeah, anyone else? I don't know if anybody noticed from the syntax, but the syntax comes primarily from either Kotlin or Groovy, because I was playing with those languages at the time and I thought they were kind of neat. A little bit of F# thrown in for fun. Okay, well, thank you very much, and enjoy the rest of the conference.